请挺出话筒。
Good morning to everyone. I received your quiz one for almost half of you. I think 37 of you up to this morning has submitted. But there are still like about 21 of you haven't submitted. I hope you have started. Okay, and then try submit as soon as possible. Okay. And I actually upload the lecture notes up to chat groups, and then I all the solution to all the exercises there. Anyone have looked at it yet? Anyone look at it? Can rule examples. Lecture note. Anyone? No, not yet. Okay. Yeah. So maybe we will not discuss every examples because most of them are repetitive, but I will choose and pick some of them which are important. So last week we already discussed until 3.29. Okay, 3.29. So hopefully you have tried out the strategy we discussed in class. Okay, and then check with the solution in the lecture notes. If you have any question, then you could ask again, and then we can try to figure out together. Okay, if not, I suggest you to try because mathematics require a lot of practice. It's not just copying, yeah. Okay, let's try prove this derivative here. And let's find the derivative of b to the x, where b is greater than 0. So it's just some scalar positive, and b cannot be 1. What happens if b is 1? What's 1 to the x? If b is 1, what happens? Sorry? If b is 1 and then 1 to the x, what's that? It's just 1. So you differentiate 1, what do you get? 0. Okay, so it's relatively easy. But if the b is not 1, then things will get harder. Okay, so how do we differentiate this? Okay. So you notice that this b to the x, right, is similar to the exponential function, okay, which is e to the x. E is another scalar, irrational number, right? So do you still remember how to differentiate exponential function? Differentiate e to the x, what do you get? Differentiate e to the x, what do you get? This is a very easy derivative that you have to remember. Differentiate e to the x, what do you get? Okay. You check back your notes. Yeah. Ex, okay? You get it yourself. It's very easy. So every time you differentiate yourself, you get it yourself e to the x. So is it possible to relate b to the x to e to the x? Okay. Relatively easier derivative. Is it possible? Can you recall the power rules, logarithm, identity, or exponential identity or not? Can you change base? Is it possible to change base from b to e? Yeah, think about it. Is it possible? Now check back your identity or the exponential identity. Anyone want to try? You change B to E or not? No. Well, I mean, like, you remember an identity that is okay. This table is still the same. So you still remember like a to the x equals to e. A is equal to e to the ln a. Do you remember this? Okay. Yeah. So we can try and use this, right? Okay, to replace this b with an e. Okay, so using that, what we will get. So how you should read this is like e to the power x, right? Okay, so you can rewrite this b as e to the ln e. Make sense? Okay. So now it's become e to the some scalar again times x. So not that this ln b here is in real number. It's just some number. Okay. Yeah, but still a bit different for e to the x, right? This one is e to the ln bx. Okay. So you could make it a single variable, right? So we could realize this function as a composite function, right? So we can write it as e to the y equals to e to the u, where u is just ln b times x. Is ln b times x. So in this case here, anyone can tell me what's the formula for chain rule? The formula dy dx equals to what? What's the formula? Need to remember this chart. Dy dx equals to dy over du times du over dx. Okay. So how to remember this? Although it's not like a fraction, but it almost looks like a fraction. Very over. It seems like you don't cancel. And this is how you remember. But it's not, the principle is not cancellation, okay? Not simplification. So we know how to differentiate EU with respect to U. It's just EU again. How about du over dx? What do you get? You differentiate linear function. Remember? Differentiate cx, what do you get? You get c, right? So in this case here, the c is ln. Okay, but remember that you are differentiate with respect to x. Okay, so here got x or not? Where's the x's? Can you find x's here? There's u only. Can we write u in x? In terms of x? How? How? So here suggests that this dy over dx here suggests that everything should be in x. Can we write the solution in x or not? Do you understand what I say? No? Okay. So, okay, if you look at this, if you still remember this operation here, right? dy over dx. Okay, it's really differentiating a function with respect to x. So meaning what? Meaning this y here actually is a function of x. Okay, it's a function of x. So after you differentiate, you should expect that your function is still in terms of x. Okay, but now any x's here? There's no x's here, but there's a variable u here. Is it possible to rewrite u as in terms of x? Yes or no? Yes. How? How? Any relation between u and x? You should go back. What? Any relation between u and x? You need to substitute what is your u in terms of x here. And so you should substitute u equals to ln b. Okay, so altogether you get ln b times e to the ln bx. Question? 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 Okay. Question? Feel free to ask. If you don't understand what I say, you should ask also. Okay, don't just ignore. Because when the material get harder, students will typically get hard to study on themselves. Okay, so you need to communicate. And communicate with your lecturer, communicate with your friend. Okay, so far. Okay. Oh, okay. So how about apply? Can you apply 3.31 to this question here? To the sec x. So you could see like the 2 here is the b, okay, greater than 0, not 1. But sec theta is not really a variable, right? Because you have a trigo function there. But what can you do to make it a variable? You can use composite function again, right? Okay, so let y to be 2 to the sec theta, sorry, 2 to the u, and then where u is just sec theta. Make sense? And then again, you can use chain rule. So the chain for chain rule is dy over dx is equals to dy over du times du over dx. So dy over du, okay, you are differentiating 2 or to the u. But by example 3.31, what do you get? What do you get? You get, so can you apply? So let me put here. Can you apply 3.31 to get dy du? Can you try what is the answer if you apply 3.31? Anyone want to try here? Is it 加糖啊? Which one is 加糖? Okay, I'll try. So if I put here differentiate x of 2 to the u. Okay, so we want to apply 3.3 u here. Sorry, 3.31. So what do we get? Yeah, 1 to 3. Let's see this one. Maybe I'll rewrite here d over dx of 2 to b to the x equal to this. Okay, so this is my formula now. Okay, so can you apply to 2 to the u? So here should be u, right? Okay. So apply formula, what do you get? Replace your v. Ln. So what's your b in this case? Is that which one? B. Ln 2. Yeah. Times e. To the power. Yes, power. Ln b. Ln 2 times x. So in this case here is u. Okay. So we got this here. So we get ln 2 times e to the ln 2 times u. Okay. So du dx, how about du dx here? So this is a standard trigo, right? Maybe you can flip up what's your formula sheets. What's the derivative of secant? The derivative of secant. trigo chapter, find the derivative of secant here. Okay, so the derivative of secant is secant x times tangent x. Okay, so it's this one. Right. So we substitute it in. Secant x times tangent x. Okay, so then you put everything together. So ln 2 times secant x times tangent x e to the ln 2, and then u is secant x here. But your question is on theta, right? Yes, so I think our x should be changed to theta. So x's are theta. Okay. Question? Any question? Any question? Yeah, question? No. Yeah.
So
Yes.
secant theta,
Yeah.
we can differentiate both sides. Differentiate y, differentiate to secant theta.
You mean like y goes to the secant theta, and then what do you mean I differentiate both sides?
No,
Huh?
use ln both sides.
Ln both sides.
Ln y,
You mean ln y goes to?
secant theta.
Okay, so you put a ln 2 secant theta, right? And then you put a secant.
Then we differentiate both sides.
You differentiate both sides.
Yeah.
With respect to what? Theta. So,
Yeah.
okay, so like this. Differentiate this one with as well secant, and times belongs to. So it's a scalar, so you can put it up. I mean like this.
Yeah.
Okay, sure. This one we will do later. Okay, this is called a logarithmic differentiation. Is this what you learned in high school? Okay. So later we will touch it again. So you need to make sure when you can apply ln. You cannot just simply apply ln on both sides, right? Because if you still remember what's the domain of the ln, what's the domain of the ln? What's the domain? For positive, only for positive number. So if your function is always positive, then that's fine. If it's not, then it's illegal. Yes, but this is always positive, that's true. So that's why you can use ln. Okay, but we will save for later. Later we'll touch this again. Here we actually have a section for this. Okay. Sure. Is anyone familiar with this kind of function? If I don't give you an actual function, do you get lost? How to differentiate? If the question is of this kind, do you know what to do? Do you get lost if you cannot see cos tangent polynomial? Not sure, don't know how to do. Okay, so well, what should you understand about this question here? So first of all, f is differentiable. Okay. Second of all is you see that inside f is not x anymore, it's something else. Okay, something else. It's not x. Okay, usually you see fx, right? But here is fx cubed. Okay, so you should think of this s cubed is like power of x. But power of x is another function. It's a power function. So actually, in this case, this is a composite of function. Okay, so this is a composite of function. Okay, so well, you differentiate every time in this course. You want to differentiate a composite of function. you will always remember that you need to use chain rule. Okay, so once you remember the chain rule, you should ask yourself how to set up the chain rule. Okay, so or you should try chain rule. Okay, but to try chain rule, you should set what's your y. Okay, what's your y? Right, maybe your y like this. Fu again. Then what's your u? Then you can set your u to be x cubed, right? Okay, but then what's the chant for your chain rule? Dy dx equals to dy du times du dx. Okay, but what's your dy du here? So if you look at this, dy du is just the derivative of f. Okay, so you can do the derivative of f because f is differentiable. Okay, so derivative exists. Okay, so if you ask me what's the actual form of this derivative, I don't know because you didn't give me the f. But what I know was I can just leave it as f prime u. That's it. That's all. Meaning the limit exists. Okay. Then what is du dx? I think du dx is easier, right? It's 3x squared. Okay. Similarly, you see here got u. U is in terms of x, so you should substitute the u equals to x cubed back. So all together, you will get this 3x squared times 4x cubed. Okay. So I hope when you come to uni, right, you can write down this step here. Then maybe like what you said in the last class, right, I can remember the answer here. Yeah, but now I hope that you can see why you can get the answer you remember. Okay, or you memorize. Right. Okay, so the step here is very important, this chain rule. Okay, because you can memorize 100 formula, 1,000 formula, but you could have 10,000 questions. Right. So how do you settle with 10,000 questions? Only principal can settle it. Okay, you cannot memorize so many. Okay, you are not machine. You are not even better than ChatGPT in terms of memorization. Okay, so how you can do better than the machine? You know, what's the difference between you and machine for now? You know, you don't know. Wow, if not, all robot will take over you someday. You know what's the difference or not? What's the difference between your brain and GPU? What's the difference between your brain and GPU? You are studying CST, right?
Yeah.
You should know what's GPU, right? No difference. Cheaper? Which one is cheaper? Which one?
Brain.
Your brain is cheaper. Okay. Cool. Right. So your brain actually is creative. Okay, it's creative. So this creativity is not be able done by machine for now. At least for ChatGPT 5.0. Is it 5.0 now? 5.0. Yeah. Okay. So because everyone will think differently, so this is your creativity. But your creativity will follow some logic. This is whatever you come and learn every day here. You actually are studying others' logic. You know whose logic is this? Derivative. Whose logic is this? Who give this? Who create this branch? Do you know? Newton. So you are studying Newton's logic, Newton's thinking, Leibniz thinking. Okay or not? So one day you can create your logic. Then we go and study your logic. So you come to school is about studying different people's logic, which is useful. Okay. So how about B? Okay, can we do B and then we can go to the next section? About B here. Can you suggest what's your Y? So you can see that this is again a composite function y. Fx is a function, and then you take it to a power 3. So this action taking power to the 3 is a function again. Okay, so what do you think you can set your y to be? What do you think? What's the basic function you can see here? You can set y to be fx.
And y.
Not very good, right? So maybe you can try another approach. Yeah, y equals to u to the cube, right? And then u is the fx. Okay, so then again by chain rule dy dx equals to dy over du times du over dx, which is 3u squared times f prime x, which is equals to 3 to the fx squared times x. Okay, makes sense. Okay, so you can see that in this example, right, it demonstrates to you that if you put the cube inside the variable or you put the cube outside the function, they are actually different. Okay, the derivative is different. Okay, the derivative is different here. In general, is different. Okay, so you see, we got 2f here. Here only got 1f. It's generally is different. Okay, so you cannot just simply pull your cube outside your variable. Okay. Any question so far? Question? Okay, if no, we will keep these two as homework. So please try it out yourself. I think these two, the technicality of these two is you need to apply chain rule twice. Okay, you need to apply chain rule twice. Because why apply chain rule twice? How many basic functions you see in 3.34? What did you see? You see a power cube, and then you see a triangle sign, and then you see a 4x. So there are three composite terms. So you should imagine you should do twice chain rule. How about here? How many basic functions in 3.35? Where's Margaret? Where's Margaret? Where's Margaret? Is Margaret here? No? Margaret here? Up here. Here. Margaret. Hello, Margaret. Morning. Morning. So can you see 3.35 here? Okay, so how many basic function in here? Two. What other? Yeah, basic function. How many basic function? Any basic function? 1, 2, 3, choose one. Yeah, two. Okay, what other? Okay. What other? Can you see any basic function in this function? Yeah, x to the power 2 is 1 polynomial, and then 3 again. So 1 is x squared, the other one? Huh? Trigonometry, so what are they? Yeah, so what are they? So what are the trigonometry functions here? What are the trigonometry? The sine and the cos. Okay, so there are three of them here. Okay, so you should try differentiate twice using chain. All right. Okay, next. Next, we will learn implicit differentiation. Okay, so maybe let's do this example then. Okay, we will sorry, we will use 3.36 okay to do as an example for this new concept here, implicit differentiation. Okay, so do you know what's a meaning of implicit. Implicit versus explicit. What's implicit? Anyone know? What's implicit? It's like hiding. Okay, something get hidden. Okay, something get hidden here. So let's see what's hidden here. So far we have given a function explicitly in terms of x. Okay, so you know that fx is e to the, for example, e to the 1 over x, or y equals to x times sine x, right? However, sometimes the curve is given by a relation that cannot be written as an explicit function. For example, x squared plus y squared equals to 25. Anyone still remember this equation here? A squared plus b squared to c squared. So this is a circle. A circle with a radius 5. Okay, centered at the origin. So in this case here, last time we already discussed that this circle here is not really a function. It's not really a function because it fails the vertical line test. Okay, so it failed. So we cannot write y equals to something in terms of x. Remember that last time we say that we can split it up, right? We can split out the upper semicircle and the lower semicircle. So if you split it out, the vertical line test will be fine. Okay. So for example, the upper semicircle is y equals to square root 25 minus x squared, and then the bottom one is y equals to minus square root 25 minus x squared. So if you split the bottom, top and bottom is fine. Let's say this is y1, and then the other one is y2. Yes. But now we're going to teach you a method such that you can straight away differentiate this equation here. Okay? Such that we can straight away differentiate this equation here on y with respect to x. Okay, so this is called the implicit differentiation. Okay, later I will show you why it works. Okay, using examples. Okay, we won't prove it. All right. So from here, from this question here, we want to find dy dx, and then find the equation of the tangent line. Okay, is it possible that we skip this part here, find the equation of the tangent line? Do you still remember how to find the equation of the tangent line? What's the ingredient to make lines? Do you still remember how to define a line? Yeah? You need to start with a point and then give you a gradient. Okay, and then you use the gradient equation. So you have a point, then you need to find the gradient. So this is what we're going to do now. We're going to find the gradient. Okay, after finding the gradient, I will leave you to find the tangent line. Okay, so the point here is how to find gradient. Okay, but you have no function anymore. Instead, you have an equation. Okay, so what are you going to do now? Okay, so let's try it. So since here's my pen. So let's suppose x squared plus y squared equals 25. Is it okay with writing this shorthand notation as xp? Suppose that x squared plus y squared equals to 25. So how are we going to do implicit differentiation here? So the idea is very simple, or the method is simple, I should say, is you just differentiate both sides with respect to x. Both sides, right? So if I differentiate both sides with respect to x, if I differentiate 25 is a constant, again, so I should get 0. But on the other side, what should I get? Felicia. Sorry? 2x plus y squared. Like that. Okay, like that. Is it? Okay. So not quite. And not quite. Why? Okay. So this is not quite. So what should we do here? So what we should do here was we should split out by linearity first. Okay, so what's linearity here? D over dx of x squared plus d over dx of y squared. Still remember the linearity. Okay, if you differentiate, the sum is equal to the sum of derivative. Okay. Make sense? Okay. And then, so here is, I should write by linearity. Linearity. So how you remember this property here was, you should remember that limit is a linear operator. Derivative is also a linear operator. Okay, these are nice function here. They are themselves operators. Now to differentiate x squared. Differentiate x squared with respect to x, what do you get? 2x. Good. But the problem here is what's this? Y squared. Sorry? Huh? 0. If y has no variable in the x, it should be 0. But the point here is, we actually, what we do here was we secretly see this y in terms of x actually. So actually we secretly see this y in terms of x. Okay, so this is the point of the implicit. So this is the implicit part here. So this x is hidden. Okay, hidden in x here. Right? So it's hidden here. So if this y is in terms of x, but you want to differentiate this thing with respect to x. This is what we see just now, right? What did we use just now to differentiate this? We use the chain rule. Okay, so we should apply chain rule here. So if I apply chain rule here, what do I get? You quickly compute. Remember just now? Here. Okay. This form. Okay, d over dx of some function to the power. Okay. So if you use chain rule here, what do we get? What do we get? So maybe let's quickly compute at the side here. So let's say, so here is y, right? So let's use other function then. So maybe w equals to u squared, and then u equals to yx, right? And then what is dw over dx here? We should get dw over du times du over dx, which is 2u times the y prime x here, which is dy over dx. So what's u here? U is just 2 to the yx, and then dy. So here we should get 2 times dyx times dy dx equals to 0. Okay, make sense? No, make sense? Okay, which part doesn't make sense? Maybe we can work back step by step. Which part? No, it's okay. Which part? From where you start? The green part or the green part? You mean why I said this? Okay, so now we're gonna differentiate this, right? Okay, so what's this green part here? So if I set this up, what's dw over dx? So actually it's d of u squared over dx, which is equal to d to the yx squared over dx. This is what we want to compute. Is it okay? Okay, so this will suggest that how we set out the chain rule. Okay, once we set out the chain rule, and then we will use the chain rule. Does it make sense? Okay, so I think the part that confused you here was maybe you are not very familiar with how to write function as composite. Okay, how to see this as a composite function. So what are the basic function here? Yx to the square. So there are two functions to see here actually. One is yx itself. The other one is taking yx to the power 2. So the action of taking power 2, right, is another function. So there are two functions. Okay, so one function is taking something to the power 2. Okay, the other one is another function itself. Make sense or not? Okay. Question? Any more questions? One more. Okay, so from here, you can easily manipulate. So let's manipulate this number. Okay. So if I move around these x's and y, I should get minus 2x over 2yx, which is what? Which is x over y like that. Okay. Okay or not? Any questions so far? So far, any question? Okay. Okay, if you are okay, I'll show you a magic now. Then let's show you a magic. So I'll show you a magic here. So if you still remember this picture of a circle here. Okay. So if I just restrict to my function on upper semicircle, right? This point of y. Okay, so let me put down here. So this point of y, hey, what color should I use? So how about use purple? So if I check this point, these are x, comma, square root 25 minus x squared here. So implies that here y will be equal to square root 25 over minus x squared. Okay. So what is 3, 4? 3, 4 is in which quadrant? So here is the first quadrant, okay, second quadrant, third quadrant, and fourth quadrant. Okay, where is 3, 4? First quadrant. Okay. So we are concerning point on the upper semicircle. Okay, so let's look at this upper semicircle function here. So if I do dy dx here, what do we get? So if I use dy dx here, how do we get? You know how to differentiate the square root function? And differentiate this or not? How to differentiate this? So this is also a composite, right? Because you have a polynomial, you have a power. So you use chain rule, what do you get? Just chain rule, what do you get? Power, bring it down, right? And then you differentiate inside. Okay, inside you get minus 2x. And then you keep 25 over x squared. And then power minus 1, which is negative 1. Okay, so you get this minus x over square root 25 minus x squared. Okay. So here chain rule, yeah. So if it is chain rule, you should set what's your y, what's your u, right? Okay, so maybe you should set y equals to u to the half, and then u is 25 minus x squared. Is this two answer the same or not? These two answers same or not? One is minus, one minus. Okay, one x. At the bottom, do they agree or not? Why agree, Felicia? And then, but there's the square root here. Okay, almost. because we already assume our y is the upper semicircle, so it's a positive square root 25 over x squared here. So it's really equals to, negative x over y. Okay, because this y here comes from the y above. Okay. But the powerful of this calculation is, if you repeat this calculation using the lower semicircle, okay, it is also the same answer. Okay, so this implicit differentiation is kind of like compute every possible cases already. Okay, you compute every possible cases. Okay, so this is the power of this implicit differentiation. Okay, we still have 5 minutes. So how about try this? I give you 2 minutes. Okay, try implicit differentiation on this question. So you should ask yourself, what's implicit here? What's hidden here? Okay. Which variable is hidden? So just now we differentiate with respect to x, x is hidden, right? Okay, so in this case also x is hidden. So hidden in where? Okay, should be in 1. Okay, so I'll try and do this. We'll discuss after 2 minutes. Okay, should we try together? So there's no function here, right? Okay, so we try to see if implicit function differentiation will work here. By implicit implicit differentiation. Okay, what can we do was we could differentiate both sides, okay, with dx with respect to dx. So I think right side is relatively easier to compute. Okay, so you just get 3x squared. Okay, but on the left side, what do you get here? You should split out using linearity here. Get d over dx of y cubed plus d over dx of 7y. The second one is easier. You just pull the scalar out. You just get dy over dx. Okay, but on the most left one is a bit tricky because you have y to differentiate. you have cube to differentiate as well. So you need a chain rule here. Okay, so if you apply chain rule, what do you get? 3y squared times dy over dx. Then you just collect all the dy over dx together, and then you divide by all the coefficients, the sum of the coefficients. Okay, I think this is the answer. Okay, anyone got this? Question? Any question? Feel free to ask. So we spend the time on the chain rule, and then after chain rule, we will quickly use this method very fast. Okay. So, but at home, maybe you should write down the step of chain rule. What's your y? What's your u? And then you do the chain step by step. Okay. And then after you do for a few times, then you will get used to it. So this step is a chain rule if anyone. Okay, got question? Question? Nope. So how about we take a break here? So let's break until 11.
无法分成这样的形式，就是无法提问。这样，可以帮我把这个文件让你们开出。对 ，PDF。啊，对，是吧？你的那个名字跟着那个我发的那个形式命名，就是让你有注意到，就是可以的。再加多一个 quiz one，那我们才知道你是交哪一份。这样子。ID 名字，然后 quiz one。哦 ，OK。Yes. Yeah, point of using this implicit differentiation. What's the point? Because
Even if we get this one,
what do you mean?
if we just straight up use the derivative, could we get a bonus?
What do you mean? How do you
We just give it a link.
talking like
Just put 3y 3y by the power of 2 plus 7 equal 3x power 3x2.
What do you mean? What do you mean? Straight away.
What do you say this?
What do you mean by straight away? Powers.
actually x or like
So what's this? How you get? What's this? Why you do it? You are just differentiate this. Add the derivative of this. Add derivative of this. So I mean, like what you do here was d over dy of y cube plus d over dy of 7, and then here it's equal to d over dx of x cube. So what's the point of doing this? This one is differential with respect to y. We want to differentiate with respect to x.
all we want.
Yeah.
Make it the same.
Yeah. Otherwise, it's no meaning. Right.
So we put this so we put this over this to make them both the same.
Which one?
And this.
Because we do the same thing. We do the same thing to the same thing.
So it makes them the same with it.
Yeah.
Ah,
Obviously, right? Because if this is a function, you should send the same thing. Same thing. You cannot send same thing to different thing.
right.
This is what it means by a function.
Okay.
Okay.
Thank you.
Yeah. All right. For those who are here, I can take the two first. Okay. Chang is what surname? Long. Yeah, I know. What's the character? What? Oh, okay. I see. All right. Sure. 陈乐天 ，OK， 陈瑞阳，陈思曼，陈意南，not here， 陈意南，陈玉涛，陈义哲，not here， 戴丽文，邓瑞阳，方泽曼，嘉来，何嘉诚，吴佳怡，黄启军，黄义清，季俊义，孔相思，雷一玲，不是雷一玲，OK。李冰珍 front right. 李家谈 Did you say you want to send me the photo? Okay. I thought I didn't receive it. Okay, 林浩云的林文琪，我是林文琪，刘汉祥，刘俊杰，刘新阳，卢万达，卢新月，OK， 罗玉鹏，马一田，回头了 ，OK， 苗冰城 at the back， OK， 倪浩然。Who are you back from the toilet? What's your name? 006. Checking. I think I'm going to check. 006? I'm sure. Is it 006? Oh, yeah, right. Chen Yinan. Okay. Desmond Tan here. Okay. Tommy here. Tommy, you okay with your quiz? Okay. Sorry for the delay. There's some system setup problem, so it didn't show up. Anyone met the quiz problem yesterday or not? It didn't show up in the first hour. You guys okay? Is it okay? Okay, good. Okay, good. Because there's some problem with the setting up, so it doesn't show up. Loa Chung Yi, Ang In Jie, Gok Pagani. Where's Gok Pagani? Samova not here. Actor is actor here, not? Seems like actor is not here. Not here. Arianto. Hisham. Where's Hisham? Daniel. Daniel, you better you? Are you better? Are you sick? Little bit? Still sick? Okay, do you take medication?
Yes.
Panadol. Huh?
I'm saying.
You're taking? Okay, good. Hashim. 1 year. Aaron. Where's Aaron? Brandon. Brandon. Felicia. Tanti. Margaret. Sleeping, Margaret. Why is it so tired, Margaret? Still sleeping. Sick. Sick. Okay. Hassan. Khalid. Yeah. Jahil. This one. Javed. Javed here. Okay. Gabriel. Where's Gabriel? Okay. Jeffrey. Okay. Purity at the front. Hân Fan. Yeah. He Ya Ting. At the back. Wu Wei Ye. Hong Thanh No Si. Guo Hongliang. Okay, so please submit your quiz as soon as possible. Please don't wait until 3 p.m. Later, internet got problem. Right. Okay. All right. So should we continue? Yeah, let's continue here. Okay. So if you look at this question here, find an equation. So Arthur just arrived, is it? Arthur just arrived, is it? Yeah. Okay. Right, so if you look at this question here, find the equation of a tangent line to the curve for x squared y minus xy equals to 3x cubed at the point 1, 1. Okay, so find tangent line. So what's the ingredient of a tangent line again? You need a point plus a gradient. Okay, so you got a point already. Okay, typically people will tell you the point first because we are concerning the tangent line at that point. So now you want to find dy dx. But now you see that, oh, this y is not in terms of x. Okay, I mean, it's not explicitly, but actually it's implicit. Okay, so you should use implicit differentiation here. Okay, so you should use implicit differentiation. Okay, right. Is everyone following? I follow. Okay, so can we skip this? Should we compute this or can we skip this? What do you think? I'll let you choose. Sorry? Compute? Okay, I give you compute. Maybe 2 minutes. We can check answer together. And try and compute and then we check. I think this question is short enough to compute everything, so you just get your equation of a tangent line. I will ask from you. What's the equation? Okay, so later give me a final answer. Yeah? What's the equation of a tangent line? Anyone finish? Anyone finish? Finish? Maybe someone can give me the equation of the tangent line. Right? Not yet. You want to try? Gabriel. Gabriel, where is your computation now? Where did you compute until? Where's your computation? You finished? Almost okay. Okay. You want done? 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 Are you done? Okay, what's your tangent line?
Y
To what? -5?
-5.
Okay. That's it. Done. You happy? Oh, okay. Okay, right. So any other answer? At the back got. Howrun got. Y equals to -5x plus plus 6. Plus 6. Okay, someone got this one also. Okay, let's check whether which one is true. Okay, let's check answer together. So then we should, in this case, because y is not explicit in terms of x, so we should use the implicit differentiation here. So what we do with implicit differentiation is we differentiate both sides with respect to x. Okay, on this equation curve here, this curve equation. Okay, so if you do implicit differentiation and do it quickly using chain rule, and I think you should use the product rule here, right? Because got the x squared or yx here, right? So you should imagine they are product of two functions in x. So if you use product rule, what do you get here? So you get 8xy plus 4x squared dy dx here. Okay, this is the product rule part. The other one is just the 3 of dy dx. And then yeah, on the right hand side, you get 3x. Okay, so your dy dx should be 3 to the x squared minus 8xy over 4x squared minus 3. Everyone happy with this derivative here? Using product rule. Okay, so here is the product of function in x. Okay, so you need to apply product rule here. Okay, so what's your product rule? U equals to 4x squared and then v equals to 1. So this is your product rule. So you want to evaluate at 1, 1, right? Okay, so evaluate at 1, 1. What is your dy dx? So you just substitute x equals to 1, y equals to 1. So you should get minus 3 minus 8 over 4 minus 3, which is minus 5. Okay, so now the problem here is how you construct the equation of line. Okay, still remember the formula or not? What's the line equation here? Okay, I like to remember it using the rational way. Sorry, what's rational way? The ratio way, okay? So the way of ratio was equation of line, tangent line. In general, is a line. The tangent line. 1, 1. Okay, so how do we compute this? So it's basically y minus 1, x minus 1 equals to minus 5. Okay, so what do you get? Y minus 1 equals to minus 5 times x minus 1. And then you move the 1 to the other side. You get minus 5x plus 5. plus 6 plus 1, so you get plus 6. Okay, so you get the second answer. Okay, so first one is correct. Okay, good. Yeah. So did you forget this part here? Did you forget this part? Yeah. Okay, so very important. You need a gradient plus a point, okay, to get your tangent line. Okay, otherwise you get different line. So if you notice here, I plot out this curve using GeoGebra. So where is 1, 1? So 1, 1 is here. 1, 1 is here, okay? And then the tangent line is like this. So does it match up or not? This linear line here, is it negative gradient? Because this direction is a negative gradient. Okay, so your y, or you're not even close to y equals to -5. Y equals to -5 is here, very far. Y equals to -5. But you should wait. Oh, okay. So, but y equals to -5x is here. And so basically, you just shift your line up. And so here is y equals to -5x. Okay. Then here is, oh, this line shift a little bit. So so your tangent line looks a bit like this. Y equals to -5. Sorry, where's your y-intercept again? Let me check. So 6. Okay, good. No wonder. So no wonder it's not like not tangent enough. So you go from 6 all the way to this one. And so this one is y equals to -5x plus 6. So y equals to -5x, something like. And if you forgot the x on your -5, it's just horizontal. Make sense? Okay. Right. Okay, in this case here, let's skip this 3.39, okay, because it's the same type of question. So you find the point such that on the first quadrant, this curve is horizontal. So what does it mean? Horizontal line. dy dx have to be 0. Okay, and then you find solution that live in the first quadrant. Okay, when the x is greater or equal to 0 and y greater or equal to 0. All right, and then this one is similar. Okay, just make it more complicated using trigo. Okay, so you should involve a derivative of trigo. So this one is similar. How about this one? Maybe we can try this one quickly. Okay. So the question here is you need to find a second derivative. Okay, so what should you start with finding? To get second derivative, what should you get first? First derivative. Okay, so let's try this. Okay, see if you are okay. To get the first one, can you quickly get the first one? You quickly do it. First one. Implicit differentiation. Okay. So you should do d over dx on x to the 4 plus y to the 4 equals to d over dx on 16, right? And so all together, you will get 4x to the cube plus 4y to the cube dy dx equals to 0. Okay, so all together you get dy over dx equals to minus x cubed over 1. Okay, so far okay? Can follow? Okay. So what I used here was linearity plus a chain rule. Then can you imagine what you need to do next or not? What do you need to do next? Well, what is y prime here? You just differentiate your dy dx again. So What are you differentiating? You are actually doing the quotient rule on this. Okay, you need to do quotient rule on this. Quotient rule on this. Yeah, you need to do quotient rule on this. Yeah, I think this step there's no implicit differentiation, right? There's nothing different implicit. This is just differentiating another function. So if you do a quotient rule on this, remember the formula, you will get minus 3 of x. Sorry, not minus. So y, wait, what am I doing here? So yeah, sure. So you still keep your scalar outside, and then you do your quotient rule on uv on the numerator and denominator. So you get something like this. Okay. And then you just continue differentiating. So what do you get? Minus 3x squared y cubed, and then minus x cubed again. So differentiate y cubed. So this is so I remind you, this is the chain rule example we started. Okay, in class just now. Okay, so you need to use chain rule here. So x cubed to the 3y squared of dy dx over y to the 6. So this minus here is outside, so be careful. Don't simply place the minus. All right. So we know dy dx, so we will substitute what we have computed just now. So we have computed dy dx is negative x cubed over y cubed here. Then we will do simplification. Okay, if we do simplification, what do we get here? We simplified it. So I should get minus 3x squared. Cancel out the y's. So we get x4 plus y to the 4 over y to the 7. Okay, so I clear denominator. I clear the denominator in the numerator. Is it okay or not? With this clearing here. Okay. So basically, I clear this part here. So here and here y. Okay, and then I multiply y on both numerator and numerator. So here become y to the 4. Okay, so I pull out the 3x squared outside. And all together, what do I get? Can you see that I can simplify this again? Because x to the 4 plus y to the 4 is 16. Okay, so we can substitute again. So we can reduce it to actually 48 x squared over 1. Okay. Make sense? Okay. Yeah. So you need to be sensitive with these equations so that you can make your solution as simple as possible. Okay, as simple as possible. Can we do it even more simple? I think a bit hard because we got a y cube here. Can we simplify y cube or not? So let's say I want to rewrite this as 48 x squared over let's say 16 minus x to the 4 of y cube. Can I simplify y cube? Is there any way to do that? Is there any way to rewrite this y cube to x? Any idea? Did I compute wrong? Anyone got different answer? Can I compute wrong or not? No, you also get the same answer. But this YQ is not satisfying. I cannot write it in X, so I should be able to write it in X. What's wrong here? Any wrong? Oh, because here I also cannot write it in the X even. So if it's possible, I should be able to write dy dx. So can I do that? Maybe you can try. Okay, if you succeed, let me know. Okay, can I write everything in Excel? Or maybe depend on where the y is. Okay, sure. Any questions so far for implicit differentiation before I go to the next part? Do you know when to use implicit differentiation? Okay, when your function, when you get an equation, okay, where the y is not explicit in X. Okay? You cannot write y equal to something in X. Okay? There's no way to do that. Because you see that this is like a multi-value function. Where there's a multiple y that can satisfy this. Okay, if no question, we'll go to the next part. So derivative of inverse trigo here. So if you just clearly look at this formula, right? I mean, you can just take the formula sheet and then apply this. Whenever you see inverse of sin x, you put down this derivative. But the point here is, how we derive this derivative is actually using implicit differentiation way. If I can show you here quickly. Yeah, but it's not tested. It's just some extra knowledge here. So if you can set your implicit function as y equals to sine inverse x and then do the implicit differentiation, you get this derivative. Okay. So maybe something worth to notice here was after you differentiate inverse trigo here, you get something in terms of roots of polynomials. Okay. Because if you differentiate sine, you get cos. You differentiate cos, you get minus sine. But if you differentiate the inverse of them, you get something in terms of polynomial. Okay, so something to note here. Other than that, just follow the formula. Okay. If you want to derive it, you need to use implicit differentiation. Okay. So how about we try one question and then see you know how to use formula or not. And I think we can skip this part. So if you want to differentiate this, what we're going to do here, so dy dx is equal to differentiating 1 over sine minus x. So this is a quotient, right? So you should use quotient rule. Okay, so you set u equals to 1, v equals to sine inverse x. So what's the quotient rule? Quotient rule formula. V prime u minus what? U prime v over v squared. Okay, so what's your u, what's your v here? So your u should be 1, your v should be sine inverse x. Okay, so what is u prime? I think u prime is 0. Okay, but what is v prime? Go to your formula sheets here. 1 over square root 1 minus x squared. Okay, so you just place 1 over square root 1 minus square. And then you just put everything in. And just sub it in. And what do you get? Kind of complicated. Quite complicated. So it's minus 1 over sine inverse of x square times square root 1 minus x squared. That's all. Okay. Very straightforward. Okay, because this is just applying formula sheets. So the hard part actually is to derive it. But I don't think we will do in this class. Okay, and then the next is differentiate y equals to x times arctangent square root x, so tangent inverse So in this case here, what rule you use? What do you think? What rule should you use? So there's a polynomial times a inverse trigger. So what rule should you use? Hashim or Hisham? Hashim. What's your name again? Hisham? Yeah, Hisham. What rule should you use here to differentiate a product? Product rule. Okay, so you just use product on this question. Okay. Next. Next is derivative of logarithm function. So we are very close to the method that your classmate mentioned just now. Okay, logarithm, make differentiation. So first we'll learn the derivative of the logarithm and at base e and a general base. Okay, so can someone notice that actually the first derivative comes from the second one? Do you notice? Do you know how to get the first derivative from the second one? How? How to get the first one from the second one? What's ln? What's the definition of ln? Ln is log what? Log e, right? Okay. So if you put e to the second formula, right? 1 over x ln e. What's ln e? 1. So 1 over x. Okay, so the second one is a more general formula here. Okay, so this one is a more general formula. So if you remember the second one, then automatically you get the first one. Okay, so so ln x is a function that the derivative is 1 over x. Okay, so this is very useful. In particular, later when we learn integration, right? Okay. When we learn integration, you can think of it as a inverse operator. Okay. It's like you differentiate this function, you get one derivative, and then you integrate the derivative, you get the what we call this as an NP derivative. Okay, so this is a relation between ln x and 1 over x. Okay, so to check whether you know how to apply this formula, let's do one question here. So differentiate this function ln square root x. Okay, so ln square root x got how many basic function here? Ln x and also square root x. So here they appear as a composite. Okay, so they appear as a composite. So to differentiate a composite function, what should you use? Composite. What rule you use? Huh? Also start with C. What rule? Huh? To differentiate. Where is Aaron sitting here? No, who are you? Bradley, Aaron, right? Bradley or Aaron? Aaron, okay, Aaron. Okay, so to differentiate composite function, what do you do? What you use? What rule you use? Composite function. Huh? No. What's chain rule for? When do you use chain rule? When do you use chain rule? You also don't know. Very important. You need to remember when you use product rule, when you use quotient rule, when you use chain rule. Okay, so can your friend help or not? What's your name again? Say again. Hosea? Is this the name I told you? What did I call you? Arianto. Okay, Arianto. So when do we use to differentiate composite function, what rule we use? Chain rule. We use chain rule. Okay, so we use chain rule for composite function. Okay, so can you see composite function here? So let y equals to ln u such that your u is square root x. Okay, so then we can use chain rule. So dy dx, which is your d over dx of ln square root x, okay, is equals to dy du times du dx. Okay, so if you do this calculation, so the differential ln u, you should get 1 over u, like what we discussed just now, times du dx is just 1 over 2 times square root x. Okay, 1 over 2. So all together we get 1 over 2x. Okay, very nice function here. Okay. Did you notice something special here? Did you notice something special here? There's a 2 appear in your original function actually. Where's the 2 appear? Where's the 2? In the square root. There's a square root there. Okay. So actually you can rewrite this function, you know. Actually you can rewrite this function. D over dx ln square root x is ln to the x to the half, right? But we can bring the half to the front first. But in that case, we can differentiate using linearity, right? So we can bring the scalar up first. Then we also get the same answer. Okay, so the nice thing about mathematics is if you work within the legal framework, okay, we should get the same answer. Okay, we should get the same answer. Okay, so this is one of the beauty of mathematics. Okay, no matter how you work, you should get the same answer. Okay. Right. Maybe we will skip 3.45. Okay. So in this case here, maybe just look at it by inspection. What rule you should use? What's your name? Green jacket, blue jacket. What's your name? Hao Yun. Hao Yun. Okay. So what do you think? What rule should you use here? Sorry? Chain rule. Okay. Why do you use chain rule here? Okay. So what are the basic function here? So next and okay. So how you combine this two basic function here? How do you combine? There are few ways to combine, right? You can take the sum, take difference, take quotient, take product, take composite. Which one you use? Huh? Which rule? Don't know. Not sure. Actually, you are taking the composite here, right? So the composite looks like what? So you should let your y equals to ln to the u, and u equals to x squared minus x squared. Okay, this is the composite function. Okay, remember last time we do the composite function calculation, fgx. Okay, you substitute the gx into the x in f. Okay, this is what we did. Okay or not? Okay, so I mean, seriously, we should write like yu equals to ln u, and then we should write ux equals to x squared minus x minus 2, like that. Okay, so we really are working on the composite functions, okay, which is the ln of x squared. Okay, does this recall your memory on fgx or not? fgx, f composed gx. Okay, yeah, it's really a composite here. So you should use chain rule here to differentiate. Okay. Right. Question. Aaron, got a question or not? I see you quite confused face. Got question? Feel free to ask. It's okay. That's fine. Maybe your friend also confused. No? Arianto, okay. Aaron. Still confused. Oh. Which part? You want to try us? Or you want to think yourself? Okay. Okay, you'll try again. Okay. So if you still get stuck, you can ask again. Okay. How about the next one? Can we do this? This one is a bit boring. Show that for any x is not equal to 0, differentiating ln 1 over x is just 1 over x. Okay. So what's the point here? Okay, what's the point here? So the point here is you need to understand what is ln x, modulus x. Okay. So there are two definitions, right? Okay. So ln modulus x is equal to ln x if x is greater than 0, and ln of minus x if x is less than 0. Okay. Can we take 0? No, right? Okay, because ln doesn't define it 0. So we have these two cases here. Okay, so well, I mean, like, what should we do here? So what should we do was we just differentiate. Okay, we just differentiate. So for two cases, so for x greater than 0, we just differentiate what is ln x. And for second cases, x less than 0, we also just differentiate what is ln. Okay. So can we quickly compute this two? So the first one, we just get 1 over x. Makes sense? We just use formula. Okay. How about second one? Okay. How about second one? Is it just 1 over minus x? No. So what should we do here? What should we do? What should we do? What's your name again? What's your name again? Yihan. Okay. So Yihan, what should we do for the second one? What rule to use? Chain rule? Chain rule, okay. So you're gonna use chain rule, what's your y? What's your u? What? This one minus angle. Then u? No, okay, no. So, y equals to ln u, and then u equals to minus x. Okay, cool. So we'll try this. So if we try this, we get what? We should get 1 over u times minus 1, which is 1 over minus x times minus 1, which is still 1 over x. Okay, so all together we get 1 over x. Okay? Make sense? Question? No? Okay. Let's move on. I think the rest is also similar. Okay, we just skip. Okay, so d over dx ln 1 plus cos x is also chain rule because the composite of ln u and 1 plus cos x. Okay, and then second one, what's this? Square root ln x here. Again, is a composite. Square root u and then u equals to ln x. Okay, composite. And then this one, this one a bit tricky. How many basic function you see? You got ln, you got cube, cube root, and then you got the rational function. So you should imagine you should do 2 types of chain. Okay, yeah, try it. Yeah, you should try. Try yourself. Okay, if everyone okay, then we will go into your friend's method today, which is called logarithmic differentiation here. Okay, so if you look at this function, right, for example, this kind of function, how are you gonna differentiate this? This is a quotient, so you might using quotient rule. Okay, after you use quotient rule, you need to use like chain rule. right? Okay, you should try to see how long it takes to reach the solution. Okay, but thanks to logarithmic differentiation, because you can notice that this function here is always positive. Okay, it's always positive. And it won't equal to 0 actually. Okay, it won't equal to 0. Here it won't equal to 0. Okay. For where it defines y, you need to make sure the numerator is not 0. Okay, but if you want to get this numerator to be 0, you should take x equals to 1 here. To define, actually it's defined actually. So I guess our derivative only work for y greater than 0. Okay, otherwise there's a problem here. I think we shouldn't differentiate at the point 0. I mean x equal to 1. Okay, otherwise there's a problem. Okay, so not that. Is greater than 0. Never x is greater than 1. Okay. Then we'll do differentiation then. Okay, so we will use logarithmic. Okay, so now I'm going to teach you what's the logarithmic differentiation here. So like what your friend said just now, we just first, just now for implicit differentiation, we apply d over dx on both sides, right? So for now, we will apply ln first. Okay, ln y equals ln of square root x squared over x plus 1. That's okay, so far so good. Okay. So you will see why this ln will make our life easier. So, but then what's the property of ln? If you ln of a quotient, what do you get? You get ln of a numerator minus the ln of the denominator. Okay, so let's rewrite it to the form that easy for us to differentiate later. Okay. But ln can reduce what? Ln can reduce the power to scalar. Okay, so let's pull the half out. Okay, so can you see the power of ln here? Ln make your quotient become difference, and then ln make your power become scalar. Okay, so that's why we like this ln here. Okay, otherwise you need to use quotient rule, chain rule, everything. Okay, so then we will then use implicit function. Implicit differentiation. We use implicit differentiation here, where we we differentiate both sides. Okay, with respect to okay. Well, okay, so for the left hand side, what do I get? Do I just get 1 over y or not? No, y. Why? Why not just 1 over y here? Why not? Good. So y is not a variable, y is a function. In particular, this is implicit in terms of x here. Okay. So in this case, we should use chain rule. Okay, so we should use chain rule here. So we should differentiate this function with respect to y, and then we differentiate y with respect to x. Okay, so here we use chain rule, we get 1 over y times dy over dx. Okay. And then on this term, what should we do here? We just use linearity to pull them out. So let's pull the sum out. And then pull the sum away. Okay, so you can see that, oh, I need to do chain rule. Okay, I need to chain rule to ln of 1 minus x squared and then ln of x plus 1. So if I use chain rule, what should I get here? 1 over 2 minus 2x over. Why I still got the square root here? Oh yeah, sure. Okay, I mean like, okay, sure. So I mean, what you get? 1 minus x squared. And then chain rule on x plus 1, what do you get? You just get 1 if you differentiate inside, and then ln x plus 1 become. And then all together, you should get, let's see, all together you should get y times x over 1 minus x squared. And then, where's my minus sign? So let's pull the minus sign out. So you get a plus 2 over 3. So I think that's it. Done. Maybe you can, let me see. Can we do something else? Yeah, sure. I mean, like, depend on how you want to how to simplify this. Maybe you could get this x. Okay. So basically, I pull the 3 up. So I make the same denominator 3. And then here, I make this factors here multiplied by x minus 1 to get 1 minus 6. Is it enough? Let me check. Yeah. Okay. The factor here is 1 minus x. Okay. So maybe someone could try. If you have tried, use a quotient rule, chain rule to differentiate. Maybe you can send me your working. We can compare how different, how long. Okay, which one is more efficient? And maybe someone can try this method too. Use the old way method too. Okay, use quotient rule, use chain rule, and then compute this. See how long is the working. Okay, once you do it, you can send it to me. See if you get the same answer with me or not. Okay. Yeah. Well, I mean, you can substitute your y back. Everything in terms of x. Okay, you can substitute it back. So you can continue this. Okay, everyone. Anyone question for this part here? So we have added a step on applying ln on both sides and then only do implicit differentiation. Anyone got question? If not, maybe we can do this one more example tomorrow. Okay, only then we go to the next part. Hey, not tomorrow, Friday. Okay, for those who haven't submit your quiz, please do it soon. Please do it soon. Okay, don't wait until last hour. Okay, see you on Friday.
上课。